Good afternoon, everyone. It's great to be here to share our view of the technology evolution from 5G to 6G. So I was listening to all these great talks this morning and kind of reminded me something a friend told me many years ago when I started my research career in industry. He said a good approach toward research in industry is two things, two sentences really. Keep your head in the cloud, put your foot on the ground. So really talk about two aspects of the things that we have to face in our day-to-day life as a person, as organization, as well as industry. I mean, we heard really good, exciting use cases about 6G for the future. By the way, I really like the slogan for this event, Mobile Career 2023, Beyond Connectivity and New Possibilities. So we heard many good use cases, AI everywhere, virtual reality, satellite communication, all very good. On the other side, I was thinking, where is our ground? When we prepare for the future, we also need to know where we are today so that we can make conscious choices, make good decisions, learn from the lessons, especially from the 5G. So that's where I want to start actually talking about where we see things are for 5G, right? We started about 4 years ago, commercialization of 5G 2019, first in Korea and also in the United States. So where are we? What did consumers and our operators, customers view? What's their experience? So you can see, this is a rough summary of what we see so far, right? It's a little bit mixed. No sugarcoating it, right? Consumer side, maybe for some market like United States, we see good improvement in the throughput, but in other places, the change seems to be a little bit more incremental. Also, operators still probably doing well. We heard the number supporting 1 billion, even 2 billion users for 5G up to this point, but also there's a bit of saturation in terms of growing beyond the current EMBB business. Of course, we are trying several new things. There's several bright spots on the horizon, including especially FWA in the United States, private network, slicing, and edge computing. So all these are really areas I think that has good promise going forward. While we see all this dynamics happening in the industry, what's happening is operators' need for technology has also been changing. Now, if you talk to the operators, they ask more and more things like energy efficiency, security, AI native, open RAN. So that's really what's happening around us. I mean, based on that, we need to think about, as an industry, as a community, what type of technology we should prepare. Right? We already saw from the previous speaker, spider diagram. So situation changed quite a bit. From 4G to 5G, at that time, you can think it's really a linear extension of all these important KPIs in throughput, in the spectral efficiency, latency, and so on. But from 5G to 6G, we are still going to improve spectral efficiency. It's very important, right? But you can see that according to at least the ITU discussion that's happening so far, that pure linear extension is coming to somewhat of an incremental end. Instead, we are looking more and more on how we can really think about the real-life user experience, how to improve that. That's why we think it's important to look at these new attributes. Okay. For example, AI native. Use these new tools of AI machine learning to solve these real-life problems, to improve the energy efficiency, both on the network side as well as on the terminal side. How do you improve coverage? Coverage remains a challenge in many countries, especially in countries, big countries such as the United States. And how do you prepare for the future of 6G? The security situation will be very different, especially with quantum computing on the horizon. Make our future network more resilient. So these are the new attributes we think will really define the future of 6G. And we need to understand this situation and prepare our technology efforts toward them. If you take a look at the more holistically, a bit of a roadmap, we saw quite a few roadmaps in terms of standardization, ITU and 3GPP. You know, 6G is going to be end of the decade. I think there's a growing consensus among the industry on that. But really, you also need to think, how do we go from here to 6G, right? Right now, we are 5G. We're going to prepare for 6G using a few key driving technologies, such as new spectrum or upper midband. We heard a lot about that. AI native RAN or even core network make energy efficiency more holistic across different entities in the network, also in the terminal. But it's also very important for us to think about how do we help our industry, our community, both on the operator side as well as consumer side in 5.5G, right? It's a long time between now and when 6G will be commercialized. So that's why 5.5G, I think it's really critical for us to consider as a community, provide good solutions, especially driven by what we are doing in 3GPP standards, 5G advanced, what's happening, for example, in other organizations such as ORAN. What's happening there is quite important in terms of front haul design, in terms of RIC, to allow this AI-based app ecosystem, for example. Okay? So this is kind of a big picture we have to keep in mind when we think about preparation for 6G. It's really not a one-time event, you know, end of a decade, but really continuously innovate to provide solutions to satisfy the need for our customers and consumers. So right now, what is happening on the 3GPP side, you know, you probably, many of you are familiar with the timeline and so on. So right now, we are kind of toward the tail end of release 18 and moving toward release 19. So lots of discussion happening. You can see the emphasis now is moving toward how do you provide a continued balance between mobile broadband and also expanding into vertical domain, right? How did you balance the need of immediate versus long-term commercial needs and device evolution versus network evolution? All these are very important points, and there's a reason in 3GPP community these are being discussed. Okay? And also, you can see that there's a discussion. 3GPP is having too many study work items, spreading thin. How do we coalesce our energy toward more critical and urgent needs of commercial deployments? We just have a lunch today. I mean, it's really, how do we really solve this problem? Because we see in the past, 15 years ago, when we did release 8, release 9, initial LTE, right? 80–90% of the specification being written there goes to commercial field in 2 or 3 years. Nowadays, situation changed a lot. We have a lot of diversity in technology, in innovation, which is a good thing, but also the time to market become longer, sometimes never. So we got to change that, bring discipline back into this community. So, you know, for those of you who are not familiar with 3GPP, this is a really short summary of what is happening on release 19. You can take a look. There's a few different categories of technology being discussed there, including continued enhancement for the technology being considered today, MIMO, for example, mobility enhancement in different working groups, but also, you know, in the middle, you can see things that's starting to become important and of interest to the broader community. Advanced duplexing solutions, introduction of AI and machine learning from release 18. More initially on the physical layer side, now moving toward the MAC layer, and mobility enhancement as well. In addition to that, you can also see we are starting to sow the seeds for preparation for 6G. In particular, as everybody is interested in expanding into new spectrum for 6G, right, in the upper mid-band. So it's important for the community to start looking at channel model, for example, for upper mid-band, ambient IoT, to name a few. So this is really what's happening in the 3GPP domain. So then, so in terms of spectrum, right, so what are the 3 most important things in wireless industry, our industry? Spectrum, spectrum, spectrum. So that's why every time we talk about new generation, it's very important to look at where the opportunities are for us to innovate. And typically, people focus more on the new part of the spectrum. So of course, we need to talk about that. In this case, I think there's a consensus that The focus is more on the upper mid-band from 7 to 24 gigahertz. I mean, details are still being worked out. I hope in a couple of months after WRC 2023, we will have more clarity on where things will be. But there's just a few examples of where interests are. For example, 13 gigahertz in the United States and 7 to 8 some other markets. Right? But it's also important to remember it's not only these new spectrum, but also existing spectrum very important. They are already there. FR1, below 6 gigahertz, FR2, millimeter wave. This morning, Ed was talking about really recapture the momentum for the millimeter wave. I think when we plan for 6G, we have to consider how to balance these new spectrum, developing technology for that, and also further optimize the spectrum that's already there. So with this, I'll move on and talk about a few of the technology preparation that's taking place in Samsung in our research areas, especially the first two will be collaboration with our partners, National Instrument and Keysight. Thank you so much. I think this is a really good example of global collaboration. I think after my talk, they will talk about a little more detail on these two topics. The first one is, but before I do that, I want to first talk a little bit on a high level, because both topics of collaboration are in the area of AI for 6G. We chose those topics because these are new topics and there's a lot of unknowns. I think that collaboration really plays a key role for us to put our resources and strength together to solve the problems faster. But look at the overall picture of 6G for AI for 6G, right? So AI is already being discussed a lot, even for 5G. Many good use cases are emerging on network planning, management, automation, performance enhancement, and so on. But if you look at the big picture, this is my way of really simply say 5G AI is applied in a more local manner. Base station side, we can apply AI. UE terminal, you can apply AI, and so on in different entities. 5G Advanced, we're trying to change that a little bit by jointly optimize, for example, the CSI compression and prediction that's happening between base station and UE. And 6G, we expect to see a more holistic end-to-end optimization across different entities, really benefiting from the ability for AI to handle nonlinearity and long-term correlation. So with this, the first topic, later you'll see more detail, is collaboration with NI. That's kind of an interesting idea. Historically, we do a back-off when we transmit RF signal, right? Whether it's OFDM, whether it's SC FDMA. OFDM maybe a little bit more because PAPR is a little bit higher. So the idea is, why can't we move our operation point a little bit to the right side of the PA curve so that you can transmit more power, then use AI on the receiver side to deal with the degradation caused by the PA nonlinearity. So that's kind of a simple idea. You can see more detail later. We can use this idea to improve the uplink coverage, also to enable these higher order modulations. Okay, so you probably hear more details in NI talk a little bit later. And the second topic is the AI-based CSI compression, the channel state information compression. This is an active topic, actually started in 3GPP release 18. Basically trying to use AI, in particularly this ability for AI to compress the information more efficiently compared to today's quantization-based MIMO codebook. So, from our study, we saw that we can potentially improve the performance of this compression by more than 20% compared to today's NR Type 2 codebook. And of course, to show that it works not only on paper, but also in reality, in the hardware, in a real-time manner, we have to put them in this hardware FPGA emulation platform. And for that, our friends in Keysight really helped us a lot to supply this channel emulator, but also help us to find a way to do the real-time performance measurement. So again, more details will be shown when they talk about their part. Okay. Of course, the AI is not limited to channel sounding or nonlinearity. For example, another work that's happening that we want to share with the world is we find a very good use case for AI as an optimization tool. In 3GPP, in Wi-Fi, we have been using square modulation for the last 20 or 30 years. It did not change. We add a lot of MIMO features, a lot of V2X features, but fundamental, this core part of communication always rely on QPSK, 16 QAM, and so on. So, but recently we realized, if we go beyond that, we can actually improve the spectral efficiency as well as energy efficiency quite a bit. Especially look at this particular example of 1K QAM. We use AI to do the search and come up with this non-uniform, non-square modulation constellation map there. Just by doing that, we went through the simulation and showed the performance gain could be as much as 1.2 dB. That is huge, just by changing how you map those bits to those constellation points in the IQ domain. That directly translating to 25% of transmission power reduction without doing anything else. So innovation like that really demonstrate the power of AI, machine learning as a new tool when we prepare for 6G and look at these new possibilities. So I want to quickly touch upon a few other things we are doing, especially when it relates to either new spectrum opportunities in FR3, this upper midband, as well as some of the things that we are doing to further optimize existing band in FR1 and also millimeter wave band. For FR3, we heard a lot today, right? So upper midband offers a really good opportunity. It's kind of squeezed between two existing 5G bands of 3.5 below 6 and also the 28 gigahertz millimeter wave band. So here, I think by and large, we think that band is really good combination of being able to provide coverage that somewhat can match what you see in C-band, 3.5 gigahertz band, by using this very advanced beamforming and array technology, but also because of the frequency, carrier frequency is higher, 4 times higher compared to C-band in 3.5, we have ability to support much higher this MU MIMO order. As a result, the overall spectral efficiency and the capacity can be drastically improved. So you see the small table here comparing these different aspects. The number of layers, for example, especially on the capacity side, we see potentially we can go from where we are today around 16 layer to 64 layer very comfortably because instead of 32 or 64 in the number of TRX or digital transmission ports, we are expecting something around 256 to be a good number. So you can support 64 layer, MU MIMO no problem. And also you can also improve not only MU, but single user experience. That's also very important. That represent the experience an individual user can possibly expect. Okay. So we did some initial simulations. This is not using 64 layer yet. This is only 32 layer. So you can see the results roughly match what we expected. This is from the system level simulation. 50 percentile throughput can be improved almost by 100% compared to where we are today in 5G. And similarly, we have a huge gain in terms of edge throughput, 5 percentile user throughput. So, but there's different assumptions being made there. Specifically, these two rows represent two numbers in the transmit EIRP. The reason we are doing that is because right now in the United States, the FCC initial guideline was 75 dBm. We thought it was a little bit too low compared to what we need to really achieve this dual goal of similar coverage and much higher capacity. So I think industry is having discussion and providing our feedback, and hopefully we can convince regulators to provide higher ERP in those bands. And another thing is, probably not obvious by looking at these simulation results, is improving the power efficiency is really critical. We did a back of envelope calculation for how much power it will consume to build a prototype today. based on today's technology, it's about roughly 5 kilowatt, okay, to send the 75 dBm of power, counting all the PA inefficiency, counting the power it takes to run the baseband modem. So that is not acceptable to any operator in the world. If you talk to them, typical requirement, doesn't matter how much capacity, how much capability that you provide, they want power to be limited to somewhere around 1 kilowatt, or at most 1.5 kilowatts. So we have a lot of work to do, really solve not only the system problems, but also build the ecosystem. We need more efficient integrated RFIC, modem solutions, antenna solutions to really come together to help us build this, future of this FR3 and enable this new spectrum. Okay, so this is a new band. Of course, new band is important, but as I mentioned, existing band is equally important. These spectrum assets are already there. But our customers really ask us a lot, how can you further improve this from where we are today? So FR1, we have a few ideas. For example, one of them that recently came into the picture is called distributed MIMO, or multi-TRP coordination schemes. So by distributing these antenna units in the cell, you kind of bring these base stations closer to the average users, and therefore you can improve the capacity while bringing the power consumption down. Okay, of course, there's a few key technology challenges we need to solve, including synchronization and calibration of these different antenna units, and as well as on the system side, providing advanced beamforming technology across these units. Maybe one last thing I want to quickly touch upon. This is more on we did some tests and it seemed to be quite successful, really approaching what we predicted earlier. I want to touch upon this FR2, especially FR2 as we understand. One of the key challenges is coverage, both downlink coverage and uplink coverage. But the spectrum is very large, very precious opportunities that's already there in many operators. So we are really looking at how do we solve these problems, and downlink and uplink, and also solving these blockage issues due to the building and so on. So at least in uplink, we found a good solution. It's called the joint phase and time array. Many people understand the millimeter wave using hybrid beamforming, right? So, which is good, power efficient and cheap, but downside is you can only send one beam to one direction at a time. That turns out to be a fundamental limitation in a multi-user system for uplink coverage, because your PA is not turned on all the time. If you have 10 users, at most you are turning on your PA 10% of the time. That's a big limitation, and we found a way to deal with that, to allow these multiple beams to be transmitted at the same time at different directions, so that all the users' PA can be turned on at all times to improve the overall coverage on the uplink. So this is kind of an illustrative results. If you can achieve that, you can really improve your coverage, because many systems is really uplink limited. Typical communication system. Okay, so you can see we published a few papers from last year. Feel free to take a look, looking at possibilities. So with this, I probably conclude my talk with this 3GPP timeline and ITU preparation that's happening. I think nothing talks about this importance of global collaboration more than looking at this ITU and 3GPP curves here. Really, you can see the complexity of building a future generation telecommunication network. So we really don't have too many years left, right? According to most people, we probably want to finish our standard by sometime 2028 and trying to commercialize by 2030. So hopefully, with a good collaboration in events like this, share the ideas, and motivate all the ecosystem partners to work together, we can achieve this very ambitious goal of bringing 6G to reality in the next few years. Thank you.